Okay. So, let us go to next problem. It is asked to examine this function f x equal to 2 sin x plus cos 2 x for its maxima or minima. So, that is find all possible local maxima, local minima, absolute maxima, absolute minima if possible, right. So, the function is 2 sin x plus cos 2 x. Now, we take it is defined everywhere on R, differentiable also. So, its derivative is 2 cos x, from sin x we get cos x, and from cos 2 x we get minus sin 2 x, and 2 x gives 2. So, minus 2 sin 2 x. That is, if you take 2 common and expand it, it becomes cos x minus 2 sin x cos x, this is sin 2 x, or that is 2 cos x into 1 minus 2 sin x. That is our f prime x. We want to find the critical points. So, where is this 0? Where cos x is 0, where sin x equal to half, fine. So, the points are 2 n pi plus pi by 6, 2 n pi plus pi by 2, 2 n pi plus 5 pi by 6, 2 n pi plus 3 pi by 2. Cos x equal to 0. So, that gives x equal to pi by 2 or 3 pi by 2 with 2 n pi addition. For any n you can vary now, n is any integer, and sin x equal to half gives your pi by 6 and 5 pi by 6 with 2 n pi added. So, these are all possible critical points over the whole of R, where n is any integer. Okay. Now, at these critical points we must find out about maxima and minima, what happens to that. So, for that purpose we differentiate it again, we get f double prime x equal to, from this it will be easier to differentiate. So, that becomes, or even from this first one will be easier still. So, that gives minus 2 sin x, and this gives minus 2 comes here 4 cosine 2 x. So, that is f double prime x, fine. Now, you must find the sign of this f double prime at the critical points. Okay. So, at A, which is, it is really A is not a single point, there are many points, depending on n this A changes. So, at all those points f double prime A is equal to minus 2 sin of that, so that should give half, and minus 4 cos 2 x of that 2 times. So, that also again gives a half. So, that gives pi by 3 comes, so it is half, and that gives minus 3, which is less than 0. So, that means all these points are local maxima of the function f of x, fine. So, what is the local maximum value? Evaluate f at A, that is essentially at pi by 6. So, that gives 3 by 2, that is the local maximum. Okay. Now, similarly, we should discuss about these types of all the 3 types of points B, C and D. So, at f double prime B, if you substitute B, that is pi by 2 in f double prime here, that becomes 0, this becomes pi. So, that gives minus 2 into 1 plus this minus, and minus 1 comes from cos 2. So, that gives 4 into 1, it is 2, which is bigger than 0. So, since f double prime of B greater than 0, at B there is a local minimum of f of x, and the minimum value is f of pi by 2, that gives 1. So, this is local maximum, this is local minimum at P. And what about C? Again at C we will try, C is 2 n pi plus 5 pi by 6. So, we go for f double prime at C, evaluate it, so it is essentially 5 pi by 6, that gives a half, and this gives a half. So, minus 3, which is less than 0. Therefore, f of x has a local maximum at these points C, and the maximum value is f of pi by 6, which is 3 by 2 again. Okay. Similarly, if you go for D, we substitute 2 n pi plus 3 pi by 2, that is 3 pi by 2 essentially. So, that gives us 6, which is bigger than 0. Again, as in B case, there is also a local minimum at x equal to C, D, and this minimum value is f of 3 pi by 2, which is minus 3. So, taking care of all these things, what do we get it, that the points of local maxima are this A and C. Okay. So, 2n pi plus 5 pi by plus pi by 6 and 2n pi plus 5 pi by 6 for any integer n. And what is the local minima? They happen at 2n pi plus pi by 2, 2n pi plus 3 pi by 2 for any integer n. And what are the values? We get from the first two, it is 3 by 2 is the maximum, local maximum, local minimum is minus 3. So, if you compare all the values, we get absolute maximum as 3 by 2 and absolute minimum is minus 3. So, that is how we are going to use the second derivative test. Let us take another problem. Now, we have a quadratic here, f x equal to a x square plus b x plus c. So, quadratic, that means we assume that a is not equal to 0, x square coefficient is non-zero. We want to find the local extrema of f of x, that is local maximum, local minimum if they occur. So, it is very straightforward. What we do is see that it is differentiable everywhere, even twice, it is a polynomial. So, f prime x gives us 2 a x plus b, and to find the critical points we equate that to 0, and all those x is minus only one point where minus b by 2 a. This is the only point where there can be local maximum or local minimum, because it is defined throughout R. So, there are no endpoints. Now, at minus b by 2 a, we have to find out whether it is local maximum or local minimum or what can be, or maybe certain under certain conditions its property will change, because we do not know anything about a, b and c. All that we know is a is non-zero, that is why minus b by 2 is well defined. So, we take the double derivative. Now, double derivative is 2 a. So, now it is straightforward. If a is bigger than 0, something happens. If a is less than 0, something happens. Specifically, if a is bigger than 0, then f double prime is bigger than 0, it is 2 a. So, it has a local minimum at minus b by 2 a, and if a is negative, then f double prime is also negative. So, it has a local maximum at minus b by 2 a. So, it is quite straightforward. Let us find what is in the next problem. We want to find the maximum and minimum values of 1 divided by 1 minus x square in the interval 0 to 1. So, at 1, of course, the function is not defined, right, as it is. So, and also we have the domain, restricted domain is 0 to 1 open interval. So, find maximum minimum values of this in the open interval 0 1, where the function is 1 by 1 minus x square. So, then you see, first thing is about the maximum. Since it is defined in 0 to 1, when x goes very close to 1, 1 minus x square becomes very close to 0. So, 1 divided by 1 minus x square can be made as large as possible by choosing our x very close to 1. So, that means, which means its limit x goes to 1 becomes infinity. Limit of course, is from one sided now, from the left side limit. So, limit of f x, x goes to 1 minus is infinity. That means, it cannot have maximum value, right. Okay. So, that is what our first conclusion. Now, when you differentiate this, this gives 1 minus x square to the power minus 1. So, that gives, it is 1 minus x square to the power minus 1, its derivative. So, using the chain rule, we would get 1 divided by, it is minus 1 into 1 minus x square to the power minus 2 into 1 minus x square with respect to x, though that gives minus 2x. So, minus minus cancels, you get 2x divided by 1 minus x square to the power 2. That is how f prime x is. So, now it is 0 only for x equal to 0. So, that means the critical point, only one critical point, which is x equal to 0. At 0, we have to see what happens, right. So, what happens at 0? For that, let us take the second derivative. Of course, you can go to your sign test, sign of f prime minus 2 plus or plus 2 minus. but let us use second derivative. Second derivative is not very difficult to compute here, again by chain rule. So, you can think of x square minus 1 square if 1 minus x square is troubling. So, that gives x square minus 1 square into derivative of 2x, which is 2, minus 2x into derivative of 1 minus x square, or x square minus 1 square, which is 2 into x square minus 1 into 2x, divided by gx square, which is 1 minus x square, same thing as x square minus 1 to the power 4. Okay. So, that after simplification gives minus 2 into 1 plus 3 x square divided by x square minus 1 cubed, 1 x square minus 1 cancels. Now, you want to find this at the critical point. So, at x equal to 0, if you evaluate it, it gives the value as 2. This goes, this gives minus 1, so 2, and this is bigger than 0. So, f of x has a local minimum at x equal to 0. In fact, that is the only extremum value, no other local minima or maxima. So, that is also absolute minimum, and its value is 1. Is that fine? Okay. Let us take one more problem. Here the function is not given, but what is given is its derivative. Its derivative is x minus 1 into x plus 2 into x minus 3. So, what is asked is to find the intervals where f x is monotonic, that is f x is increasing or f x is decreasing. So, throughout the interval it should happen, right, that is the meaning of increasing or decreasing in an interval, or it is monotonic in the interval. Then we also are required to find the points of local extrema of f x, local maximum and local minima. Okay. So, how do we proceed? We have f prime x. So, that gives us the critical points, which are 1, minus 2 and 3, fine. Okay. So, these are the critical points. At these critical points, what happens? And since we want to find the intervals, so these 3 points break the whole of R into 4 parts, right, 4 different intervals. Now, we have to discuss the sign of f prime in all these intervals. Okay. So, first is it is minus 2, then comes 1, then comes 3, it is like this. So, one interval is from minus infinity to minus 2, and then from minus 2 to 1, then from 1 to 3, and then 3 onwards. These are the 4 intervals. Okay. So, on minus infinity to minus 2, when x is smaller than minus 2, so we see the sign of it, x is smaller than minus 2. So, here somewhere x, now x minus 1 is negative, x minus 2 is also x minus of minus 2, which is also negative, and x minus 3, that is also negative. So, f prime is negative on minus infinity to minus 2. Similarly, you find on minus 2 to 1, so again it is positive, because it is inside one point is minus 2 to 1. So, x minus minus 2 is positive, other 2 are negative, that gives positive, and the other one is negative again, because 2 of them becomes positive, 1 is negative. So, it is negative, and on the other side it becomes positive. So, f prime is really changing sign at minus 2, it is changing sign from minus to plus, it is changing sign at 1 from plus to minus, it is changing sign as at 3, which is from minus to plus. Everywhere it is changing sign, but the nature is different. Okay. So, f x is, you may say, it is decreasing, since it is remaining minus on minus infinity to minus 2 f prime. So, f is decreasing on minus infinity to minus 2. Similarly, it is increasing, because it is positive here, increasing on minus 2 to 1, and it is again minus on 1 to 3. So, it is decreasing on 1 to 3, and it is plus on 3 to infinity. So, it is increasing on 3 to infinity. Accordingly, you have f x as local maximum at x equal to 1, it is changing from plus to minus. So, local maximum at x equal to 1, and local minima at x equal to minus 2, it is minus 2 plus, and also at 3 minus 2 plus, right, local minima at x equal to minus 2 and 3. So, let us take one more example. Here the function is given as x square times square root of 5 minus x. We want to find the intervals where f x is increasing or decreasing, okay, and then its local and absolute extrema. That would be quite straightforward. All that is we have to do is differentiate, and where it is defined, it is of course 5 minus x should be greater than or equal to 0. So, x should be less than or equal to 5, that is our domain, that is from minus infinity to 5 closed, that is the domain. So, there we find f prime x equal to this, except at 5 we have this one is the derivative, not at 5. So, it is for minus infinity to 5 open interval, any point x, this is the derivative. Okay. So, the critical points will be x equal to 0 and x equal to 4, right, and the point x equal to 5 where f prime is not defined. Is that okay? This f prime is not defined. So, we have these are the possible points 0, 4 or 5 where we should discuss. Now, if you look at the signs of f prime x, instead of taking f double prime, which will be a bit complicated here, we go for the sign change in f prime, that is E g. So, we find that it is negative for x less than 0, 0 is a point, right. We have the 4 intervals now, minus infinity to 0, 0 to 4 and 4 to 5, right, and then 5 to infinity. These are the 4 intervals where we should consider. Now, f prime is negative for x less than 0, positive for 0 to 4 and negative for 4 to 5, and after 5 we do not have, because function is defined only for x less than or equal to 5. So, there is no question for this, only up to 5. So, that is how the signs of f prime x are. Therefore, f is decreasing from minus infinity to 0, and it is increasing from 0 to 4, and it is again decreasing on 4 to 5, and you get the local maximum minimum value. So, you get f prime x negative to positive, it changes sign at 0 from negative to positive. So, there it has a local minimum, and it is positive to negative at 4. So, there is a local maximum at x equal to 4. And what about 5? 5 we do not have anything, you have only negative for 4 to 5, that is all. But it is an end point. So, it says that f of x is decreasing on 4 to 5. So, 4 to 5 it is decreasing, it is an end point. So, you would say that 5 is also a local minimum point, right. So, that is why you say f x has local maximum at x equal to 4, and f you can evaluate, which gives 16, and local minima at x equal to 0 and 5, that happens to be same here, whose value is 0. Is that fine? So, we stop here.